Hi, everyone. Thanks for tuning in to this session on full stack observability for a successful cloud migration. So I'm Rishi Divte, Principal Technical Product Manager at Sumo Logic, responsible for Sumo Logic solutions, apps, and partner integrations. So today I'm delighted to have Shruti join us from Tokio Marine HCC. So with that, I'll pass it on to Shruti to introduce herself.
Thank you, Rishi, for the warm welcome. I'm Shruti Anantharamu. I'm a Senior DevSecOps and Cloud Solutions Architect at Tokio Marine HCC. I'm a safe agilist with multi-cloud experience and a background in software development, solution, and enterprise architecture. I serve as a liaison between the enterprise applications, DevOps, cloud engineering, and security teams. I'm also an active member on the Enterprise Architecture Review Board.
Thank you, Shruti. So in this session, Shruti will start talking about TMHCC and their digital transformation initiative. She will then discuss their technology and observability strategy, followed by results and business outcomes of their efforts. She'll then discuss next steps in their journey and share her 3 key takeaways. I'll then conclude with a quick recap of our AWS observability solution. So Shruti, I'll pass it back to you.
Thank you, Rishi. TMHCC is a leading multinational specialty insurance group, and we underwrite more than 100 classes of specialty insurance, including liability, casualty, property, and others. Tokio Marine HCC is part of Tokio Marine, a premier global company founded in 1879, with offices in the United States, Mexico, and continental Europe. We come with deep expertise in our chosen lines of business, and we also offer integrated products covering the complex requirements of clients in the marine and aviation industries. Digital transformation at TMHCC was an initiative that started a couple of years ago, and I joined the organization in the past year and have been involved ever since in the DT efforts. Now let's talk about the business drivers. The key business drivers for digital transformation are captured in the slide. The first one is to meet the KPIs for the best possible end user experience. By end user experience, I'm talking about code generation and pricing capabilities, lead generation, as well as aggregators. From an end user experience, as I mentioned, we have direct to consumer apps that are in the Asia Pacific region, as well as in the US region. And cross-region latency becomes a very critical part for us to satisfy low latency requirements for the business units. For cross-region latency improvements, the impact is getting the codes faster, so we can also meet aggregator performance guidelines as well. Business already reported that our end user experience in our direct-to-consumer platform for code generation required improvements. We used our extensive telemetry data from our APM to ratify the services that were slow to perform. From an architecture perspective, we started what I call a DDD light exercise, a domain-driven design light exercise. As part of this, what you see on the screen is a bird's eye view of the event storming workshop. Event storming workshop was facilitated by bringing together domain experts and technical experts to discover the domain of interest and the pertaining events to build out the microservices. In this process, ubiquitous language and context maps were discovered to enhance our domain-driven design efforts. As part of this process, it was discovered that pricing microservices was the one that we were going to pull out and build a microservice from the monolithic legacy application. So from a technology perspective, we had to choose a strategy to build out our microservices. Let's talk about what we did to build out our microservices. From an enterprise strategy perspective, AWS is our cloud platform of choice. And as I mentioned in the previous slides, data residency becomes a very critical part. Our end users are in Asia Pac region, as well as our end user portals are hosted in Asia Pac region. Data residency is critical for us to achieve low latency when it comes to end user experience. Going over to the next, which is portability. Today, we have apps that are hosted on on-prem VMs or servers, and we chose to go with containers to improve our portability and use container orchestration systems as well in the cloud to improve what we can do from a scalability perspective. This also allowed us to be elastic, to scale up and down using a container orchestration system, as well as the cloud native abilities to scale up and down a cluster of nodes. Moving on to the tech stack, we are primarily a Microsoft .NET shop, and we use .NET 4 framework, framework here at TMHCC. We had to move from .NET 4 to .NET 5. One, the reason being end-of-life considerations, and the other one being portability. Since we chose to migrate to Linux containers in the cloud, we had to move to .NET 5. The other thing I wanted to talk about is the cost. We chose to move from SQL Server to PostgreSQL in order to mitigate the licensing costs that we were going to incur when we moved to the cloud. We also chose to go from Windows servers to Linux servers to reduce the costs. What we have here is the high-level architecture diagram of our pricing microservices. On the left-hand side, you see the prospect and the business to consumer portal. A prospect is a person who is a prospective insurance holder that is coming into our direct to consumer app or our B2C portals to get pricing plans. Behind the portal, what you see is Cloudflare WAF, which is a web application firewall, which is a requirement by our enterprise guidelines. And behind the Cloudflare WAF is Amazon's API gateway, which we leverage to front our microservices due to its ability to provide us with rate limiting, throttling, as well as multiple usage plans based on our clients. On the left-hand side, you also see the developer portal. The developer portal is an AWS open source portal that we leverage today so that we can provide our client developers a means to self-serve. When I say client developers, from a pricing microservices perspective, this is an offering that we provide at TMCC with the Corp Enterprise Applications Group. We do have business units who have their own developers. A business unit could be a travel insurance provider, could be a specialty insurance provider. It could be property insurances, casualty as well. They have their own development teams, and these development teams can then leverage our self-service developer portal to consume our pricing microservices. What you see right in the middle is our pricing microservices. These are hosted on Amazon EKS. They are containerized in pods, Kubernetes pods, and these are fronted by network load balancers. What you see on the right-hand side is our third-party rating engine, which is hosted in Azure platform. And what you see at the bottom is our RDS PostgreSQL instances, which are backend for our pricing microservices. What you also see at the bottom, green, is logging and monitoring service. And that's where we leverage Sumo logic to feed all the logs that we capture in the cloud native environment from CloudWatch, from CloudTrail, as well as API gateway into Sumo logic. From an observability requirement and challenges, we had a few requirements from an observability perspective and also a few challenges. Collection of log data, aggregation of the log data, be it metrics, logs, and traces for the entire app to provide us with observability across the entire stack was a requirement. Apart from that, due to the fact that we were using serverless components as well as platform as a service components, we needed cloud native monitoring. Encryption of data in transit and at rest was an org-wide security requirement. The challenges that we faced with different formats, be it CloudWatch logs, metrics, CloudTrail logs, and API gateway logs. Due to the fact that we leveraged AWS Management Console within multiple AWS accounts, we had to go into log groups to avail some of the CloudWatch logs. Even with some of the dashboarding capability within AWS, it was harder to get a single pane of glass across multiple accounts and multi-regions. Another aspect was that we had security restrictions to AWS Management Console across different groups, infra ops, operations, cloud engineering, and DevOps teams. What we ended up doing is, with great partnership from Sumo Logic, we used their AWS observability stack to use the AWS CloudFormation template and enable their observability stack within our AWS prod accounts and our non-prod accounts. We also leveraged a subscription filter for API gateway logs. Using the observability stack and the API gateway log monitoring, we built out a custom dashboard. And Sumo Logic, while it provides out-of-the-box dashboard, we had a need for a custom dashboard for different groups, be it application operations team, be it developers from our group, as well as infrastructure operations groups. Here, what you see on the left-hand side is API metrics. You also see container insights, as well as write throughputs for AWS RDS. You also see the average latency. You see how the API calls requests are performing. You also see errors, as well as you see API gateway logs and container logs. From a container log perspective, if I had to use AWS Management Console, I would be seeing multiple log groups, each for a single container, as well as live containers, as well as past containers. I had to click on these log groups, go through them to figure out and wade through the information that is available from a logging perspective. What we did through the custom dashboard is to make sure that we could filter out on the dashboard all the errors pertaining to the containers, as well as API gateway logs. I'll give an example of an incident where there were microservices were returning some errors, and we had to go in and triage. So from that perspective, we went in, we saw some errors in the container logs, and these container logs, since I could look at the region, I could also look at the account, and I could also look at whether it was a non-prod account or a prod account, and namespaces as well. I went in to look at the logs and streamlined that this was a connectivity issue between the containers or the cluster that hosted these containers and RDS. This helped us triage, greatly reducing the time to triage this incident. If I were to go into AWS Management Console, into different accounts, different regions, go through all the container logs. This single pane of glass really helped during that incident. Now let's talk about the results and the business outcomes from productionizing our microservices. So as part of the results, from a microservice perspective, what we also did before productionizing this was to add performance tests. Load and fault tolerance testing proved the results of horizontal scaling, elasticity, and self-healing that we achieved through our move to containers and the usage of container orchestration system like Kubernetes as a managed EKS. I'll give an example about it. From an elasticity perspective, as we increased the load, we saw that the horizontal part scaling kicked off, and we saw the elastic nature that we wanted as part of the load testing. And then we also saw it scale down when the load reduced. Another part was self-healing. When we issued a command to bring down a container, we saw that it healed by trying to bring up a new pod or a container that was healthy. Another thing that we also, as part of the results, was achieving unified visibility for centralized log monitoring as well. With distributed systems, the single pane of glass for incident and problem management is critical, and we use Sumo logic to reap those benefits. Let's talk about the business outcomes. We use multi-account, multi-region CI/CD pipelines, and this led to faster deployment. Another important aspect was increased turnaround for feature development, and we could achieve this by domain isolation. This also led to increase in lead generation as per business. What we also achieved was decrease the latency from 7 seconds to sub-second. I'd like to talk about a business code. We use pricing aggregators in the travel insurance industry, and there is a requirement to return faster quotes or rates in order to meet the requirements from our pricing aggregators. And we achieved this through our build out to microservices. Let's talk about the next steps. We're continuing our domain-driven design efforts to migrate additional microservices to the cloud. And another part is to include our configuration microservices in the observability stack provided by Sumo logic. We would also need to add proactive monitoring in order to integrate with our ITSM tools and also our chat tools.
So we've also been working closely with Shruti to determine how we can further optimize their observability initiatives. And two key next steps have come up. The first is to start using a new capabilities for Kinesis-based collection of CloudWatch logs and metrics. This helps in better throughput, lower latency, and predictable pricing on the AWS side. Secondly, we're going to help her teams start using our Root Cause Explorer add-on for quick troubleshooting. So Shruti, now I'll pass it back to you to talk about your key takeaways.
I'm a firm believer that the right cloud migration strategy can pay off rich dividends for the organization and also result in great business benefits. We do have complex modern distributed systems, and these require monitoring across the stack. And this was achieved through Sumo logic for us today. This also makes it easy for our ops teams, for our development teams to get a single pane of glass to view the entire system and perform to the best of their abilities.
Oh, thank you so much, Shruti, for sharing your experiences. So now what I'd like to do is quickly recap key features of our AWS observability solution. So firstly, you can either use CloudFormation like Shruti was doing, or Terraform scripts to get multiple AWS accounts and regions onboarded with the solution in minutes. We also have numerous out-of-the-box dashboards and alerts based on CloudWatch logs, CloudWatch metrics, CloudTrail logs, and load balancer access logs. These are built based on best practices as well as recommendations from AWS. And finally, we have a Root Cause Explorer add-on that I mentioned earlier, which helps you accelerate incident resolution by visualizing anomalous events of interest across multiple AWS services. So with that, both Shruti and I would like to thank you for listening to this session. Feel free to contact us via email, or if you're listening to this live, feel free to ask us any questions in the chat.